when we are multiplying powers with the same base, so multiplying meaning taking the product of, with the same base, we will keep the base the same and add the exponents. So same base in this case of A. We are multiplying powers, so taking the product of powers, I'll keep the same base and add the exponents. In this case, I will keep the same base of 2 and add the exponents. This is called the product of powers rule, or the product rule for short. If you forget the product rule, for example, in 2 to the third times 2 to the fourth, that I'm just going to keep the base the same and add the exponents, you can write the expression in expanded form to help you remember it. So 2 to the third is a base of 2 multiplied by itself 3 times since the exponent is 3. 2 to the third times 2 to the fourth. 2 to the fourth is base of 2. So 2 times 2 times 2 times 2. So 2 multiplied by itself 4 times since the exponent is 4. Expanded form, 3 factors of 2 multiplied by 3 factors of 4 makes me see that I'm multiplying 2 by itself now 7 times. So my simplified form is 2 to the 7th. So if you memorize the product rule, great. Add the exponents. If you forget, oh, do I add? Do I subtract? Do I multiply? Then go ahead and write the expression in expanded form. And then just count the number of factors. There's 7 here. If this is a reasonably sized value, I might ask you for the value. So 2 to the 7th, let's see, 2 squared would be 4, times 2, 2 to the third would be 8, times 2, 16, that's going to be 2 to the 4th, times 2, 32, 2 to the 5th, 2 to the 6th, multiply that by 2 again is 64, and then times 2 is 128. So not too big. Value of 2 to the 7th is 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 128. So if you cannot remember the product rule, you could write this out as x times 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 x. I think I said that right. Which is going to allow you to see there are 9 x's. X times 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 x. Yes, it takes a while, but if you're just guessing, write it out, x to the 9th. When there is not an exponent given, that's an invisible exponent of 1. So 3 times 3 to the 4th is 3 to the 1 plus 4, which is 3 to the 5th. That happens here too, so I could have a product of more than 2 powers. This is a product of 3 powers, but they all have the same base, so I can just go ahead and add those exponents. 6 plus 1 plus 2. So d to the 9th power. D, is that a 6? Yep. Okay. Now this only applies, the product rule only applies when the bases are the same. So base of x squared times x to the third is x to the 5th, but I cannot then add 7 since I have a different base. So x squared times y to the 7th times x to the third simplified is x to the 5th, which is x squared times x to the third times y to the 7th. If there happens to be a coefficient in front of one of the powers, meaning a number being multiplied by that power, just keep that coefficient. So let's apply the product rule. X to the 4th times x to the 5th is x to the 9th, 4 plus 5. And then I just keep the coefficient of 3. Same thing here, k squared times k to the 3rd is k to the 5th. Coefficient of 4. R to the 3rd times r to the 8th is r to the 11th, times r squared is r to the 13th with a coefficient of -2. If there is more than one coefficient, I'm going to use the product rule for my powers and then just multiply the coefficients. So 2 times 5 is 10, w squared times w to the 5th is w to the 7th. Since multiplication is commutative, this is 2 times w squared times 5 times w to the 5th, which I can rewrite like this. 2 times 5 times w squared times w to the 5th, just 10 times w to the 7th. -7 times -9 is 63. And then apply the product rule to my powers with a base of q. q to the 11th times q to the 8th is q to the 19th. 6 times 8, always paying attention to my negatives, -48. Ooh, and a tricky one, I have s to the 3rd times t to the 8th. You may feel that you can somehow combine those, but you can't. We have a different base, so we have our final simplified expression, negative 48 s to the third t to the eighth.